Hello there, Mr. Sutton here with the Pre-Cal Honors 8-1 Extra Practice Number 2 solutions on arithmetic sequences and series. For this problem, we want the 33rd term of a sequence, an arithmetic sequence that starts with -4 and 6. So we're going to use our nth term formula for an arithmetic sequence, a1 plus d times n minus 1. We have an a1 value of -4. N is going to be 33 because we want the 33rd term. For the d, we need to do 6 minus -4, basically figuring out what do I have to add to -4 to get 6, which is 10. So then we have -4 plus 10 times 33 minus 1. And let's see here. This is just going to be -4 plus 320, which is going to be 316. For this problem, I want the 40th term of an arithmetic sequence that begins with 77 and 69. So I'll use my nth term formula, a1 plus d times n minus 1. For my common difference, which they did not give me just yet, I need to figure out what am I adding to the first term to get the second term. So 69 minus 77 gives us -8. So then I've got the 40th term equaling my first term, 77, minus my common difference of 8 times we have an n value of 40 because we want the 40th term minus 1. So let's see here. Let me do this on the calculator. So plugging all that in, we end up with -235. On this problem, I want the sum of a series that begins with 3 and ends with 39, all 10 terms of that series. So let me use my arithmetic sum formula here. I have an n value of 10 because there's 10 terms in the series. A sub 1, they told us right out here, was 3. And then A sub n, that's just the last term, the 10th term, 39. So we've got 10 times 3 plus 39 over 2. And I could do this without a calculator. So this is really, let's see, 10 times 42, which is 420, divided by 2 is going to be 210. On this problem, I want the sum of the first 15 terms of a series that begins with 17 and ends with 91. So let me use my arithmetic sum formula, n times a1 plus an over 2. I have 15 terms, so that's my n value. a1 they said was 17. an is just my 15th, my last term of 91. So we have 15 times 17 plus 91 all over 2. And I'll use the calculator for this one. And when I'm doing this on the calculator, I'm going to do alpha y equals just to get my fancy fraction format so I don't have to worry about PEMDAS or parentheses or any of that. So 810 is what I should get here. On this problem, I want the sum of this arithmetic series. Let me start with my formula, n times a1 plus an over 2, my arithmetic sum formula. So I have n, that's 50. A sub 1 is my first term of 5. We don't have a sub n yet. We don't have the 50th term yet. And we need that to use this formula. So I'm going to use my nth term formula for an arithmetic sequence, a1 plus d times n minus 1. And we're just using this formula to find the nth term. So we have an a1 value of 5 plus a common difference of, let's see, 10 minus 5 is also 5, n value of 50. So that's 50 minus 1 in there. So let's see here. I've got, well, if I were to actually to distribute this out, I would have 5 plus 250 minus 5. So that's just going to cancel and give me 250 for my 50th term. Plugging all that in now, I've got 50 for n, 5 for a1, 250 for a sub n, all over 2. Let me use the calculator for this. So plugging all that in, my fancy fraction, that's going to come out to 6,375. On this problem, trying to find the sum of this arithmetic series. So we have 33 terms in this series. They've given us the first 3. I'm going to use my sum formula to start us off here. So n times a1 plus an over 2. I know I have 33 for n. a1 I know is -3. That's my first term. We don't know an, though. That's going to be my 33rd term in this one. So I'm going to use my arithmetic nth term formula, a1 plus d times n minus 1. So this is going to, our 33rd term is going to be our first term, -3, plus the common difference, -11 minus -3 is going to be -8, times, we have an n value of 33 minus 1. And I'll just use the calculator for this. Plug in all that in, we get a 33rd term of negative 259, which I will now plug in for a sub n up here in this formula. So I've got 33 for n times negative 3 plus negative 259 all over 2. And definitely need the calculator for this. Plug in all that in, we end up with negative 4,323. On this problem, I want the sum of this arithmetic series. Let me start with my arithmetic sum formula, n times a1 plus an over 2. This gives me my shopping list of things I need to get the answer here. So I've got an n value of, well, I don't actually know. We don't know how many terms there are, so we're going to have to figure that out in a minute. A sub 1 is 13, my first term. A sub n is the last term, that's 587. But I'm going to have to find the n value. So I'm going to use my nth term formula, a sub n equals a1 plus d times n minus 1, in order to work backwards and find that missing n value. So that means I need to know an, a1, and d. Well, a sub n, that's 587, equals a sub 1 is 13. The d value, the common difference, is just second minus first term, so 27 minus 13 is 14. All that times n minus 1. Doing a little algebra now. Subtracting 13, this is going to be 574 on the left. And distributing the 14, that's 14n minus 14. Adding 14 over here to get the 14n by itself, that's going to be 588. And I have no idea what that is divided by 14, so let's use a calculator. And calculator says 42. That's a nice whole number. Awesome. All right, so I know that I have 42 terms in this series. So I can now write 42 times 13 plus 587 all over 2. And let me see. I'll just use a calculator on this. So all of that comes out to, let's see, 12,600. On this problem, I want the sum of this arithmetic series. So let me see here. We've got my formula, n times a1 plus an over 2. This is the sum of an arithmetic series. And I know the first and the last term, a1 and an, are 19 and 55. I don't know n, so I'm going to need to work backwards and figure that out before I can use this bigger formula here. So I've got my nth term formula I can use for this next task. A sub n equals a1 plus d times n minus 1. And this formula, if I know what the nth term actually is, and I also know the first term and the common difference, I can work backwards and figure out how many terms were in the sequence. So we have an is 55 equals an a1 value of 19 for this one. Common difference is going to be 23 minus 19 is 4. So doing a little algebra now, 55 minus 19, that's going to be, let's see here, 36. Distributing the 4, we have 4n minus 4. Adding the 4 over here, that's going to be 40. Divide by 4, I can do that without a calculator, that's 10. Let's plug it in and see what we get. So we have the sum of the 10 terms here is going to be 10 times 19 plus 55 all over 2. And I'll just use a calculator to be on the safe side for this one. So plugging that in, we end up with 370.